Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Hi, everybody. I hope you're staying cool. It's hot out there tonight. All right. Tonight, I'll be doing a review for Quiz 1 and Quiz 2. And as I have in the announcement, which you got an email, on this Wednesday at 8 a.m., or maybe a little earlier in the morning, I will be giving quizzes 1 and 2. And at that time, I'll be emailing you the passwords for quiz 1 and quiz 2. They're the same password. Why make your life hard and difficult? It's the same password for both. You'll have until Friday, the 27th at 8 p.m. to take quiz 1, take quiz 2, and upload your answers, separate files, one for quiz 1, one for quiz 2, as a single PDF file for each quiz to the assignment area of Blackboard, just like you've been doing labs. And this is important. I reserve the right to subtract up to 25 points for anybody who doesn't follow instructions. That means especially uploading a single PDF file for each quiz, or if you don't upload it on time. If you're a couple minutes late, no, I'm not going to take off points. But if you're supposed to be there Friday night and you come Sunday and upload it, I'm going to take off points. So please don't. Now, quiz 1, and I'll be doing the review for both of these, but I'll cover this now, has 3 pages, 9 problems, 2 multiple choice. It's worth 50 points. It covers chapters 1 and 2 from the book, and you can find the videos for that. Hopefully you've been watching them. And the practice problems, along with you should know the number of protons and electrons from the periodic table for each element, and the names and the chemical symbols of the elements from the periodic table. And I'll cover that later tonight. And quiz 2 has 4 pages, 18 problems, 6 multiple choice, and that also is worth 50 points, and it covers chapters 3 and 4. Now, if we were face-to-face, I'd give you about 30, 35 minutes. If you've done the practice problems, you should be able to do each quiz in about 25 minutes or less. And to do well, as I've been saying all semester, you should be watching the videos and doing the practice problems. Now, one thing that's changed up until almost the end of last fall semester, for many years, at the end of a quiz or a test, I'd have important information, certain formulas. The end of February, fall, about 2/3 into that, the chairperson of the chem department put out rules, and one of the rules was outlawing that. And I follow the rules. So even though you'll see in the video, I'll say, well, here's important information, you don't have to memorize it. Unfortunately, you do. And for these quizzes, what I would have given would be the formulas for conversion of temperatures. Now you've got to memorize them. Now, you can't see it, but I'll show you. This is my view. Here are the 2 quizzes. Here's the PDF file. When you go to download that, you will be asked for a password, and use the same password for quiz 1 and 2. I give you the periodic table you should use. And here are instructions for how to take a test. I think in there they talk about a version number. That's back when I taught 2 sections online. I'm not, so you don't have to worry about the quiz or test version. And in case you haven't been using it, Here's links to Cab Scammer, how to use that. And the same thing for quiz 2. You can't see this, but I can. And you'll download quiz 2. And in each of these, just like a lab, you'll upload it. One thing, if you haven't noticed, except for the contract, and hopefully, I think there are 3 people who haven't submitted a contract. Please do it. Notice the labs I have always in blue, and you'll find the quizzes will be in red, the titles. All right. Now, later on tonight, I'll be posting a video of this meeting. All right. Now, if you go to Blackboard and you go to course information and then lectures, here's a copy of the periodic table you'll be using for quiz 1, 2, and all the other quizzes and the tests. And if you scroll down, you'll see quiz 1 and 2 review, both as a MS Word file and a PDF file. And these are the slides I'll be using today, and you'll be able to access them. And I have the reviews for the tests and the other quizzes and all that, but we'll get to that another day. All right, let's start the review. I started out the semester talking about the 4 branches of chemistry, and those are organic, inorganic, physical, and analytical, which you should know. By the way, organic's the best, but then I'm an organic chemist. Now, the next thing, and this is very important, I asked you to learn the names and the chemical symbols for the following elements. Now, if we look at the periodic table that you'll be using, it doesn't have the names, it's the symbols. And you have to know H is hydrogen, Li lithium, O over here is oxygen, my favorite one, carbon, because organic chemists use all the molecules have carbons in them, and hydrogen and nitrogen and oxygen. And you should know something like Cl is chlorine, Ar is argon, Kr is krypton. By the way, in our world, unless I've been hijacked to another universe, or in our world, krypton is a colorless gas, not a green solid that kills Superman. And you should know not the whole periodic table. Certain things on here I have never used and never will. You won't. Like Lr, I know is lawrencium, and that element, I will bet all the money I have that you will never use lawrencium in your life. But carbon, oxygen, nitrogen, yes, they're in the food you eat, the air you breathe, nitrogen, oxygen, and even the clothes has carbon, nitrogen, oxygen, or mainly carbon, oxygen, hydrogen. So you should know these, I think there are 39 or somewhere, not the whole periodic table, but you should know like Cu is copper. So if I ask on the quiz, what's the name of the element with the chemical symbol Cu, you should know that's copper. Or if I ask on a quiz or test, what's the chemical symbol for copper, you should know it's Cu. Now, the next chapter we went into are the metric, starting to talk about the metric system. And the metric system uses various prefixes to designate numbers for different types of things like mass, weight, volume, and other things. And I asked you to learn 3 or 4 prefixes. Kilo is 10 to the third, like a kilogram is 1,000 grams. Milli is 10 to the minus 3, or 1,000th. A milliliter is 1,000th of a liter, and centi is 10 to the minus 2. A centimeter is 100th of a meter. And those you should know. Now, next I covered scientific notation, and you should know how to convert a number to scientific notation. And here, the decimal point in the number, in the decimal number, is moved to the position behind, meaning to the right of the first number. Now, the exponent for the exponential term, 10 to the power of something, is equal to the number of places the decimal point has been moved. The exponent is positive if the number is 10 or greater. The exponent is negative if the number is less than 1. And one I never use, but you might sometime in your life, the exponent is 0 when the number is between 1 and 10. I never do that. You should know how to convert a number to scientific notation. Hold on while I turn on my tablet. So if we were to take this number, and if I were to ask, write it in scientific notation, if there is, or if there was a decimal, it would be right here. Or if there isn't any, you go to the end and you move it to the right of the first non-zero number. And here you count the number of moves. 1, 2, 3, 4, 5, 6. Now, zeros at the end without a decimal, you drop. And therefore, what is the power? Well, we moved it 6 times, so that would be 1.25 times 10 to the 6. And if you look at the videos, I have examples, same thing in the practice problems. Let's do one more. And if we look at this number, there is a decimal in the front. And now we want to move it to the right of the first non-zero number. 1, 2, 3. We moved it 3 times. Lead zeros you drop. So this would be 3.46 times 10. Now this number is less than 1, so the exponent on 10 is minus, and we moved it 3 times, so this would be 3.46 times 10 to the minus 3. Now, one thing I should caution you is if I were to have this, zeros after a decimal that are not lead zeros are not dropped. Zeros after a decimal point that are not the lead zeros are not dropped. And what I'm talking about is this 0. Now, hopefully you can all see in red. If anybody's colorblind, please let me know. All right, so how would you write 0.0410 in scientific notation? Well, you move the decimal point to the right of the first non-zero number, 1, 2. You drop lead zeros, so it'd be 4.1, but this 0 is after the decimal, not lead, so we keep it. This number is less than 1, so it's times 10, and this is going to be a negative number, and we move the 2 times, And that's how you do it. 4.10 times 10 to the minus 2. And this is a skill you should know how to do. And now, when we're dealing with numbers, there's something called significant figures. And you should know how to determine for a number how many significant figures are in that number. And all non-zero numbers are significant. Zeros may or may not be significant. Zeros leading at the beginning of a number are never significant. Confined zeros, those between non-zero numbers, are significant, and trailing zeros, those at the end of the number, are significant if a decimal is present in the number. Trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. And hint, don't you love when I'm subtle? Hint, know how to determine significant figures in a number. And if we were to take 4,135, how many significant figures are in that number? Well, all non-zero numbers are significant. So it'd be 1, 2, 3, 4. This would have, and I'm going to abbreviate, 4 significant figures. Now, if we were to have this number, notice there's no decimal at the end or in that number. So all non-zero numbers are significant. These. But these zeros at the end, no decimal, are not. So this would only have 2, and I'm going to really abbreviate, significant figures. Now, zeros between non-zero numbers like this are significant. So how many significant figures in this number? Well, all the non-zero numbers are significant, and this zero would be significant. So it'd be 1, 2, 3, 4, 5, 6 significant figures. Now, zeros at the end where there's a decimal point are significant. And there's a decimal point right there. So the question would be, you need to know how to figure how many significant figures in this number. Well, all non-zero numbers are significant. There's 2. But now these zeros at the end with a decimal point are also significant. So this would be 1, 2, 3, 4, 5. So this would have 5 significant figures. And that's a skill you should have. Now, when it comes to scientific notation, like this number, and there is a decimal here, you forget about this right here for your significant figure. You just look at this number. So this is where all non-zero numbers are significant. There are 3 of them. This has 3 significant figures. Now, when you're doing multiplication division, you get a number. Sometimes you'll have to round off. And how do you round off? If the first digit to be deleted is 4 or less, simply drop that 1 and everything that follows. If the first digit to be deleted is 5 or greater, then that digit and all that follows are dropped, and the last remaining digit is increased by 1. And this is a skill you should have because on quiz 1, 2, 3, 4, 5, and 6, and tests 1 and 2, and the final, I will have, please use proper significant figures for all calculated answers. And we'll go through that tonight. So rounding off, and for this class, it's mainly going to be a number like this. And the question would be, round that to two significant figures. How would I do that? Well, if I want to round this off, keep the first significant figure in front, 3, keep the next one 4, and that's my two significant figures. Then I'll use the 6 to round off. Is that 4 or less or 5 or greater? And time's up. Hopefully I'll pick 5 or greater. So I'm going to drop this one, this, and this. But because this number is 5 or greater, the last digit I keep, I increase by 1. So to round that off, that would be 3.5, and that's how you do it. And if you were to have this number, and let's even make it a scientific number, how would you round that off to 4 significant figures? Well, you look at this and you keep the first 4 non-zero numbers. 1, or first 4 significant figures, because one of these after decimal could be a 0. So that's 1, 2, 3, 4. The next one after the number you don't want to keep, after the last one you keep, you use to round off. And I use that double squiggly line. And that is the number 1. Is 4 less? Is 1 less than 4, 4 or less, or 5 or greater? And time's up. I like my special effects. Don't answer that question. Anyways, so it's 1, 4 or less. So I drop this, 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 and this. You keep the exponent part. So this would be 6.753 times 10 to the third. And that's how you round off numbers. Now, there are operational rules dealing with significant figures that you should know for quiz 1 and 2, mainly the multiplication division. Later on in the semester, we'll do addition. I don't think we ever do subtraction. But anyways, for multiplication division, the number of significant figures in the answer is the same as the number of significant figures in the measurement that contains the fewest significant figures. Let's say that, say that again. The number of significant figures in the answer is the same as the number of significant figures in the measurement or whatever numbers you're using that contains the fewest significant figures. Notice I have here a little hint, know how to do this for multiplication division. And if I were to ask on a test, what's the answer to that? And don't forget to use, it will say, please use proper significant figures for all calculated answers. Well, 2 times 2 I know is 4, hopefully you do, but we have to have proper significant figures. All non-zero numbers are significant and zeros after the decimal are significant. So this has 2 significant figures. This has one non-zero number, but two zeros after the decimal. This has three significant figures. And multiplication division, this is multiplication, you should have the same number of significant figures as the number you're multiplying or dividing that has the fewest. So this is 2. Now, this number only has one significant figure. And if you want to increase it, put a decimal and a 0. And now our answer has two significant figures. Now, where this really plays an important role if I were to ask you to do that, and here we have our calculator, and I have a video how to use it. I'm going to turn it on, clear it, make sure it's in scientific notation, and I'll put in 1.56. Then I'm going to do second key, and then right here in yellow, you see the double E. So I'll press second key, double E, and you'll see the E is on there. And now I'll put the number 5. So now I have 1.56 times 10 to the 5th, and I'm going to divide it, use this key right here, by 3.47. I put that in. Now notice it's 10 to the second, and you're going to do second key, double E, and notice there's an E there, and now I'll put the number 2. And I'll hit equal, and my calculator gives me this monster number, 4.495677233 times 10 squared. Now, if you write that down, I'm going to take off 1 point because you didn't use proper significant figures. Well, how do you do that? Well, this top number, all non-zero numbers are significant, 3 significant figures. This bottom number also has 3 non-zero numbers, 3 significant figures. And therefore, when you multiply and divide, this is the divide or division, you get the same number of significant figures in your answer. Oh, this is a good one. This is going to show you even something a little more tricky. I didn't plan on it, but it's good. And therefore, we have to round that off to 3 significant figures. So I'll keep the 4, keep the 4, keep the 9, and I'll use the 5 to round off. And that's 5 or higher. So all this I'm going to drop, and I'll increase this by 1. Well, that will give me 0.1. And you add it to the 4, and this rounding off would be 4.5. Now this becomes 0.10. So we'll have that become a 0. We added the 0.1 to the 4 times 10 squared. And if you notice, this number is 3 significant figures. And that's where you use rounding off. One thing I should mention, let me get rid of something. During the quizzes, Wednesday, Thursday, and Friday until 8 p.m., if you have any questions, email me. Remember, in my class, there's no such thing as a dumb question. And if we are face-to-face, if a student has a question, I'll answer it. I'm not going to give you the answer to a problem, but if you need clarification, do that. Also, just to remember, Wednesday night, I'll still have my office hour. So if you need help with something or have questions, come on by. And that will be Wednesday night. All right, let's continue with the review. All right, two things I didn't mention, I should mention now, and that is I think I did this in the videos for chapter 1 and 2, so you should know this for quiz 1. If we look at the periodic table, the number in the upper right-hand corner of each little box for that element, like hydrogen has 1, that's called the atomic number. And you should know, hint, that the atomic number is the number of protons and electrons in that element. Again, the atomic number equals the number of protons and the number of electrons in that element. So let's go back and look at our friendly neighborhood periodic table. No, it's not Spider-Man, but still, I like to say that. And if we look at carbon, chemical symbol C, atomic number is 6. So carbon has 6 electrons and 6 protons, and you should know that. If we look at iodine, right here, it's got atomic number of 53, and that has 53 electrons and 53 protons. Oh, let's go to the high rent district. Au is gold, expensive metal, and its atomic number is 79. And gold has 79 protons and 79 electrons. Again, the atomic number, the number in the upper right-hand corner, like 79 for gold, Au, tells you the number of protons and number of electrons. And you should know that. You'll be given a periodic table, so you don't have to memorize it, but you do have to know the chemical symbols and their names. If I were to ask how many electrons and protons does gold have, you would first have to know that the chemical symbol of gold is Au. And then you can look at the periodic table, look at the atomic number, and find out how many protons and electrons. Now, at this point, we're sort of into, one more thing I do want to point out that I mentioned for quiz 3 in the videos, and that's the chemical formula, the empirical formula. This is water, H2O. And here, this tells you what elements, and the number to the right, subscript, tells you how many atoms of that element are in there. So water, how many atoms are in water molecule? We have 2 hydrogen plus 1 oxygen, and that would be 3 atoms. Let's look at another one. This is sodium chloride, which you should know the name and the structure later on this semester. And you also call this table salt. That's the white substance, solid, powder, that you put on things like your French fries. I've got to watch my blood pressure, so I've cut back on my sodium chloride salt. And this has one sodium, one chlorine, so there are two atoms in sodium chloride. Now, during the semester, you'll learn about parentheses. And when you have parentheses, I'm talking about this and this, you look at the number to the right of the closing parenthesis, in this case, 2, subscript, and that you multiply times the number of each atom in the parentheses. So this would have how many atoms? 1 magnesium plus 2 oxygen plus 2 hydrogen. And that equals 5 atoms in magnesium hydroxide. And that's something you should know, how to count how many atoms are in this is called the empirical formula. Now, in chapter 3, we're starting to cover material for quiz 2. And I talk about matter. That's anything that has mass and occupies space. Now, when it comes to matter, there are certain physical states you should know. And that's the three states of matter. And notice I have it in red, which means it's important. Hint, and you should know that a solid is something that has definite shape and definite volume. A liquid is something that has definite shape, indefinite shape, but definite volume. And finally, a gas, like the air you're breathing, and I am. Yep, I'm breathing it, has indefinite shape and indefinite volume. What does that mean by indefinite shape? Well, if I were to take the water in this bottle, and right now it's a liquid, trust me, I'm a chemist, I know these things. Oh, sorry, bad humor night. But anyways, it takes the shape of the bottle. If I were to pour this in a glass with a different shape, the water would take the shape of the glass. Say it was oval. I have never seen personally for to buy, and I'd probably one day if I ever saw it, are square glasses, square rectangular, as opposed to most of them are round. But if you notice, this bottle has different indentations and everything, and that's what it means by indefinite shape. So you should know the 3 states of matter: solid, liquid, gas. And you should know a solid has definite shape and definite volume. A liquid has indefinite shape and definite volume, and a gas has indefinite shape, indefinite volume. Now, when we talk about substances, there are different types. One is when we talk about pure substances, one is the elements like hydrogen, carbon, iodine, and then there are compounds. Water is not an element. Water is made up of elements, but is a compound, sometimes called a molecule. We'll cover that later. Now, you can also have a mixture where one substance is mixed with another one, but neither lose their chemical identity. Example would be if I were to take this water and put in some sugar, I could make a mixture and it would be water and sugar, but I can take out the water and recover the sugar. Now, when we talk about substances we have things called physical properties and chemical properties. I won't ask you what is a physical property or chemical property, but you should know examples of each. Now, physical property generally involves a change of state. Example, the melting point of water is when it goes from a solid to liquid, would be a physical property. Now, chemical property is the ability of it to change. Example would be water is not flammable, but gasoline is very flammable. It burns, and that's a chemical property. Please don't try that at home or anywhere else to prove that. Now, physical and chemical changes are things that when something undergoes a change. Now, a physical change would be an example of ice cube melting because it's undergoing a change of the physical property. Now, chemical change would be when you burn a candle. The flame is caused by the wax being undergoing a chemical change, otherwise known also as a chemical reaction. Now, there are different conversions. There are three types of scales of temperature. For very low temperatures in gases, and we'll cover this later in the semester, Kelvin, K, and it's not degrees, it's just absolute Kelvin or Kelvin. And you convert from that to degrees C or degrees C Celsius by degrees C plus 273 equal Kelvin. Now, the other two are Fahrenheit and Celsius, also used to be called centigrade. And to go from centigrade to Fahrenheit, you add 1.8 times degrees C plus 32. Now, the 1.8 and the 32 are exact numbers and don't play a role in significant figures. And finally, degrees C is equal to, and let me rewrite this right here. When I did this, another way of writing it would be degrees F minus 32, then divided by 1.8. That's why I have it written that way. And remember, for this one, you do the subtraction first and then the division. And these are three formulas, unfortunately, now you have to memorize. And hint, you'll need to know that for quiz 2. So how do you memorize it? You write it down and say it 5 times one day, and you do it again another day, and that will get burned into your brain. Like if I were to say degrees F equals 1.8 times degrees C plus 32. Degrees F equals 1.8 times degrees C plus 32. And so on 3 more times. And that, excuse me, that's how you memorize this. And you should know how to convert from Fahrenheit to Celsius, Celsius to Fahrenheit, these two. You should know how to go from Kelvin to degrees C or degrees C to Kelvin using this formula. I've never had to do it, and therefore I'm never going to ask you to go from Fahrenheit to Kelvin because that would involve 2 calculations. It's not real world. All right, now in chapter 4, which will be on quiz 2, let's talk about some chemistry. Now Dr. White's having a good time, smile. And that is, first of all, the atom. You should know that the atom is the smallest particle of an element that retains the characteristics of that element. So if you look at my ring, it's gold and it has certain characteristics. And if I had an atom of gold instead of my whole ring, it would also have those same characteristics. because an atom is the smallest particle of an element that retains the characteristics of that element. Next, you should know the subatomic particles. You know what a submarine is: sub, under, marine, water. That's a boat that goes underwater. And no, I'm not going to ruin your night and start singing Yellow Submarine by the Beatles, even though I know the words. No, I'm not going to ruin your night. But anyways, a subatomic particle are the particles smaller than an atom. And the subatomic particles are the particles that make up an atom. And you should know they're the electrons, protons, and neutrons. And if we were face to face when I first teach this, I have the whole class. Let's go, class. What are the subatomic particles? I have this slide or similar, and I point to everybody, the electrons, protons, and neutrons. You should know this. You should also know the electrons are subatomic particles that have a negative electrical charge. The electrons have a negative charge. Protons are subatomic particles that possess a positive charge. Again, the protons have a positive charge, and that's negative sign here, positive sign here. And the neutrons are subatomic particles that have no charge associated with them. By the way, I don't know if any of you are familiar with the old cartoon Jimmy Neutron. If I had done that, I would have named them Jimmy Electron, because those are where the fun is. All right, so you should know the electrons, protons, neutrons. Electrons, subatomic particles with a negative charge. Protons, subatomic particles with a positive charge. And neutrons are subatomic particles that have no charge. Now, you should also know that an English chemist, Thomson, used what we call the cathode ray to experiments to prove that electrons have a negative charge. This was about circa 1900, 1905, and it was an important thing. Now, in an atom, in the very center of the atom, you have the nucleus. And you should know the nucleus is the center of the atom. And you should know that Rutherford's gold foil experiments, and now I'm going to use a very fancy word, elucidated the nucleus of the atom. And elucidated means figured out or explained. And what they found was the dense nucleus only contains protons and neutrons. And you should know the nucleus of an atom, any atom of all the elements, or each element, contains only protons and neutrons. In a later chapter, you'll learn that the electrons are outside around the nucleus. So, nucleus of the atom, center of the atom, and it contains only the protons and neutrons, and Rutherford's gold foil experiments showed about the nucleus. All right, I already gone through the atomic number. That's the number of protons in the nucleus, which is, since all atoms of elements have a net zero charge, the atomic number by definition is the number of protons, but it's also the number of electrons. Now, when we look at the periodic table, the columns are called families, and they have names. And there are four of those I want you to know: the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And you should be able to give examples of those. So let me teach you that if you haven't figured it out. Now, in the first column, all the way to the left, but not including hydrogen, it does not include hydrogen, are the alkali metals. And the important ones are lithium, sodium, potassium. I didn't ask you to learn about rubidium or cesium or francium, but those right here, but not hydrogen, are the alkali metals. Go one over to column under the number 2. Those are the alkaline earth metals. And the two important ones are magnesium and calcium, even though Dr. White likes strontium, because when you put it in a fire, it turns the fire red, like in a fireplace. But anyways, magnesium and calcium are example of alkaline earth metals. Now, if we go all the way almost over to the second to last column on the right, under the number 7 here, you see fluorine, chlorine, bromine, and iodine are the important ones. Those are the halogens. Have you ever heard about halogen lights? Because they contain halogen gas of those elements. But again, you should know these are the halogens: fluorine, chlorine, bromine, and iodine. Now, the very last column under the number 8 are the noble gases. Now, they used to be called, when I learned chemistry, inert gases. Then about 1995, that's not that long ago in the history of mankind, this seems like yesterday, that was when a very inventive chemist, I don't know his name, was able to react the inert gases. Well, he couldn't call them inert anymore, and that's when they changed them to the noble gases. So in the column under the number 8, those are the noble gases like helium, argon, krypton. And you should know, if I ask, give the name and example of a noble gas, you should be able to name one of these. And that's your periodic table. Don't forget the number in the upper right-hand corner, like for neon, Ne10 is the atomic number, and that tells you the number of protons and electrons, 10. Now, when we talk about elements, there are different designations, and one you should be familiar with is a metal. What is a metal? You know, like my ring is a metal. This is not. This plastic, that's not a metal. Well, metal, first of all, is an element, and it has the characteristics of luster, thermal conductivity, electroconductivity, and malleability. Luster means you can shine it up and make it shiny. Thermal conductivity, it conducts heat. If you think about your pots and pans at home, they're metal because you want the flame, if you're cooking over in a gas stove, to conduct through the metal of the pot into the food you're cooking. Now, wires we use for electricity are made mainly out of copper. Now, some very expensive, the old calculators had gold wire in there too, and those conduct electricity. And finally, malleability is you can pound on it and make it very thin. And if you've ever seen aluminum foil, that's coming from a piece of aluminum. They put them through rollers, press it to make it thin like that. Now, you should know examples of metal like aluminum, copper, iron, silver, gold, and so on. And with that, I'm just about done. One thing I should point out, in problem set 2, I think it is 5D, where I have 10 to the 6th, something times 10 to the 6th, it should be 10 to the 8th. Sometime tomorrow, I'll put out an email about that mistake. Bad Dr. White, bad Dr. White. But one of your colleagues let me know about that. Yes, I make mistakes once in a while. Now, I'm going to say goodbye in a little while, but I will stay around after I say goodbye. If anybody who's here tonight has any questions, I'll be more than happy to answer them. And you know what I'm going to do next. If you've been watching my videos, I talked about one of the finest women I've ever known in my life. That was my grandmother, my mother's mother. What a woman, strong, fine, so kind too. And whenever we go to her house and leave, our family, my mother, father, my sisters. We were young. I was. Yes, I was at one time. But anyways, she'd always say in Yiddish, "Gang gesund," which means go in hell. And since I started teaching online because of COVID, I've been doing that ever since. So I'm going to say "Gang gesund," go in hell. And I'm also going to say goodbye. Stole that from Granny and the Beverly Hillbillies. Goodbye.